Okay. So, I can't find my list anymore. Ah, here we go. So, we're going to do two population means again. And this is from an experiment. We have given, we're going to see the effects of calcium on blood pressure. Now I need a pencil. I was going to write it down, but then I don't have a lead. Always. Okay. Does this one have a lead? No. Does this one have a lead? It's a pen. Alright, so we're going to look at the effects of calcium on blood pressure. So we're going to have, we're going to do a controlled randomized experiment. We're going to we got 21 volunteers apparently, and they're all men. And 10 of the men we're going to give a calcium supplement to. 10 men get a calcium supplement. For 12 weeks. And 11 men get a placebo for 12 weeks. And we're going to test and see if these calcium supplements lower blood pressure. And she just now saw the pink? Okay. She is doing her test. All right. So after 12 weeks, they had their blood pressure taken on day 1, and then they had their blood pressure taken at the end of 12 weeks. Yes, ma'am? Over in that stack. So, Alexa said you're going to do lunch. It's okay. No problem. There you go. Alright. So at the end of 12 weeks, we take their blood pressure again, and we're going to see if their blood pressure is lower. So, for the 10 that were on calcium, the mean amount that their blood pressure, the amounts that each person in our sample's blood pressure was lowered, was 7, -4, 18, 17, -3, -5, 1, 10, 11, and -2, it looks like. So that means if your blood pressure was lowered, and that should be a good thing, then you have positive numbers. And if your blood pressure was actually higher than at the beginning of the study, you get these negative numbers. Okay? And then for the ones on the placebo, we had -1, 12, -1, -3, 3, -5, 5, 2, -11, -1, -3. So, as you would suspect, let's throw these into our calculator since we're using the calculator today. Let's do list 1 for the group that actually got the treatment, list 2 for the group that got the placebo. So my question is, do we see a bigger decrease in blood pressure from people who take a calcium supplement? I have two populations, people who take calcium supplement and people who don't. So I have two population parameters. So I'll call one of them U sub C. That would be ones that take a calcium supplement. And this mean is their mean decrease in in blood pressure. So mean decrease in BP for, I guess we're going to call this just men who take calcium. And in real experiments, they do several levels. But I think in this experiment, we only have one level. And we could call the second group, I don't know that I want to call them just a placebo group, because really the population is not a placebo. The population is people who don't take calcium supplements. So I'm going to call them U sub C with a line through it. Makes more sense to me. So this is the mean decrease in blood pressure for men who do not take the calcium supplement. Okay. And my null and alternative hypotheses would be that there is no difference between those two populations for my null. And my alternative is do we see a bigger decrease? That's supposed to be bigger. So my alternative is that the people that get calcium will experience a larger decrease in blood pressure. So a larger average decrease in blood pressure. Okay. So, and you can write those out in the other way. Remember, you can write these as minus equal to 0 and minus greater than 0. Both are fine. So my step 2, if you'll name your test and name it well, then you save yourself a bit of work in the next part of this operation. So this is going to be a significance test for 2 population means. We'll use the t-distribution, and we have 2 independent samples. Okay. Check my conditions. We do not have a simple random sample. We have a controlled randomized experiment. How do you think that this experiment was randomized? Ladies? Back to class. By age. How do you think they randomized? Not how do they order. What do you think they randomized in this experiment? Who gets the placebo and who gets the calcium needs to be assigned randomly. And now you have a randomized experiment. Lauren? Lauren? Thank you. Okay. And then for normality, what should I check for normality of the sampling distribution? Outliers. So, now I put this data into my calculator, so I should be able to graph these. What happened here? I thought I put list 1. Let's try list 2. Okay. We okay? How did I get both the box plots on at one time? Well, I went second stat plot, and I went into stat plot number 1, and I did